Hello and welcome back to an episode of the CTO Show with Mehmet. Today I'm very pleased joining me. Originally, he settled in the San Francisco on the West Coast, but today he's in Singapore and he's late and in his night. And thank you for that. I want to welcome Eugene Cheah. He's the CEO of Featherless AI. As you can guess from the word AI, we're gonna discuss as in all the recent episodes about AI, but today from a different perspective, like a topic which is personally I'm passionate about it, and we're seeing a lot of changes in that domain. So basically we're going to talk about how we can utilize the AI in a much better way. We're going to talk about GPUs, we're going to talk about the APIs around the AI. And I think I don't want to steal the time from you, Eugene. Just for people who might not know you, tell us a little more about you, your background, your journey, and what brought you to start Feederless.
Yeah, so I'm Eugene. A little bit of a background about Featherless AI is that we are an AI startup that is trying to make all of the open source AI accessible. What brought us here is that we actually originally started as an AI research company, and we still are, where we were trying to work on next generation AI architectures. That is like 100 or 1,000x cheaper in inference based on the RWKB architecture. So we were one of the first AI architecture and models under the Linux Foundation, and we were iterating on that next generation architecture. Uh, as we brought it into market, we quickly realized that hey, most people are actually excited about the current generation, and the next generation may require more research to do maturity. But we decided to start applying what we knew about the next generation into the current generation models to optimize AI inference. And but more importantly, we wanted to make AI accessible. One thing that I say many times is like my grandma speaks 7 languages, but she doesn't speak English or Chinese. And when I see the world of AI that is being presented, when I was a kid, I like to see, like, imagine the world of Jetsons, where everyone has their own AI robot helping their family. Not a world of AI where it's like centralized to a handful of models, and not particularly a world where the AI is dominated only by the English speaking models or the Chinese speaking models, but multiple models around the world that can represent each of us uniquely. And that is the world that I'm trying to build with Feathers by trying to make all of the AI models instantly accessible. And and so where we started from AI optimization and research, trying to make AI much more cheaper and efficient, we quickly went on to just not just about making it cheaper to run, but more accessible so that everyone around the world in this future economy can have access to AI.
Great. And thank you again, Eugene, for being here with me today. Now, of course, before I come and record with my guest, I try to do some research and see, a couple of things that you might have, said here on maybe other podcasts or maybe in other medias. So I called something interesting, and it's related to maybe more the hardware. So you described the AI hardware race as StarCraft battle between Nvidia's Protoss, AMD's Terran, and Huawei's Zerg. Like, what does each strategy optimize for, and which one do you think wins the inference era?
Well, you really dig hard on that one. I think I can't remember. Yeah, I was planning to write an article on that, but I haven't wrote an article on that. That yeah. So the I think it's very easy to portray the three, especially for those who are familiar with the StarCraft terrain Zerg analogy. For those who are not familiar with this video game analogy, the this the Protoss is the high tech. Think of it them like the elf like or the extremely futuristic tech race, and they are the most expensive units in the game. So they are extremely expensive, they're extremely powerful, and they are the best at what they do. Uh and so that is reflective on Nvidia's pricing actually. Nvidia is the market leader. They have some of the best hardware in the market and they are priced at a premium. Terrains are the humans in the game of the race, and they tend to be more. They are still fairly advanced in tech, and they tend to be more practical, more nitty gritty. you can build them in larger numbers because they are much more cost effective than the Protoss, but they get the job done and they are extremely effective units. Zergs take the most extreme approach where they are the insect race and where they are the cheaper units, and they are none of the Zerg units are like as strong as the terrain units or the Protoss units, but they make it up in numbers. And this is actually quite a useful reflection between the three, because the terrain or AMD, their hardware is good, and in some cases on par with some of the best of Nvidia's hardware, and they are doing that catch up respectively. They may not be as polished or as refined as the best hardware, but they get the job done. The Huawei chips that right now that's being developed mostly within the Chinese market are, in part because of the current trade restrictions and all that, they may be inferior in specs. The latest Huawei chips are the equivalent or even still inferior to the Nvidia A100. But a lot of analysts may end up dismissing, oh, it's behind. But they forget that if there's one thing that China does well, is mass manufacturing.
Mhm.
And because they are not dependent on the supply chain that the rest of the world is, they can manufacture at a much larger numbers. The other major thing is, if you keep track of the AI race, a lot of the bottleneck is not just the hardware, it's in energy capacity. And within China, that it's building up the largest energy rollout right now of any country. And they are able to tap to this much cheaper energy as they roll this out. So it's really the zergs of the AI inference landscape, because while that hardware may not be as good for training, it is perfectly fine for inference. And for every one high-end Nvidia chip, you you can probably buy 10 Huawei chips, and if the energy cost is cheap enough, you can outnumber it.
Right, Eugene. I'm happy you brought up, the bottleneck of the energy, but there's another bottleneck we started to hear recently about. Because people think it's only about the GPUs and who's have the access to GPUs. There's a lot of I would say causes for what's happening, which is and I think some people might have heard about it, which is the high bandwidth memory. It's like it's abbreviated as HBM. Do you think like this is another hidden constraint for AI infrastructure? And what happens if AI economics is from compute perspective available, but in terms of memory it's not?
So right now, okay, so right now the main bottleneck is still energy, to be clear.
Hmm.
Like from what I understood from a lot of data center providers, they literally have the high-end GPUs chip on standby, waiting for energy to come online. So this includes with the HBM and everything. But I understand where the concerns about HBM come from, because in particular, it's the one thing that even consumers feel right now. Like your laptop RAM and your desktop RAM has tripled in price, in part because of the demands of AI for HBM. And in particular for high bandwidth memory, because it shares the uh, same manufacturing line as standard computer memory, or memory in general. This is led in part by the demand for larger and larger AI models, and running at larger and larger context length. So you may have heard, some people may have heard like, oh, the AI model is, let's say, some of the best open AI models. No, open source AI model is like 1 to 2 trillion parameters. Then you will also hear like, allegedly, because this is not public figures, like the major closed stack models are like 5 or 6 trillion parameters. When we say trillions of parameters, you can convert that as terabytes, give and take, of GPU memory. Yeah, there are some techniques like FP4 quantization that may halve the amount. We're still talking about terabytes of GPU memory. And GPU memory, VRAM, is much higher speed, higher bandwidth than your PC memory. how many of us own a computer with a terabyte of memory, let alone GPU memory? And so that is the second tier bottleneck. Uh,
Mm-hmm.
and in particular, as we're trying to push the models bigger and bigger with longer context, that there is that heavy demand for. However, research is already actively being done to reduce this demand. Um, so you may have heard recently, like Google's TurboQuant paper. Uh, Alternatively, like for most of the open source models right now that's being developed, it runs on what's called the MLA attention architecture, which kind of reduce the memory consumption from traditional attention architecture by 1/10 for each request. Likewise, on our side, the research that we do is on linear attention architecture, which some of it has already been applied into the latest Quen 3.5 or 3.6 open source model, where those layers are essentially 100 reduced of memory usage. But because they only apply to 3 or 4 of the layers, so you can think of it as only 1/4 of the memory usage. And we will keep researching in this direction so that we can like manage the memory demands for the AI models respectively as we improve of it generation by generation. But until we go through the inflection point of rolling out the hardware, that's where the HBM is in short supply.
Right. A lot of points, that I want to follow up, but I will take them one by one.
Yeah.
Now, so again, when in the introduction you mentioned about, like, why you build featherless, and it's about, the what you call it, the model pluralist, right? Why do
Mm.
you believe the market eventually shifts from the few giant models to thousands of specialized ones? Like, what's the philosophy behind it?
The it's the same rhythm that we actually see happening within the open source space that happened in the past. I have Whenever anything becomes too valuable, we as developers cannot help but try to replicate it to get a share of the pie. And whether is it backed by billionaires or millionaires, we will try to ensure that happens. And one major example that where history has played out is within this space is itself, let's say, computer server technologies, operating systems, or even more specifically like database technology. Like, take for example, when the IBM DB2 first came out before the dot com bubble, you
Mm-hmm.
can hear analysts and experts saying the same thing. Oh, they spent millions at that time, worth billions now, to develop this fundamental piece of database technology. No one can compete with that. And then, as the cost to develop these things go down, subsequently, you hear MS SQL or Oracle SQL, or these are like competing database technologies from other major players that comes in, and then you start hearing people say, "Oh, you can't compete." It'll be these three giants will dominate the market, which is
Mm-hmm.
at the stage that AI had. So for databases, that took 5 years. For AI, it took less than 2 years. And then the next wave beyond that, it'll be, hey, there's the MySQL, which is one of the first major open source database. And then subsequently you hear, oh, let's try something different. No SQL. And then subsequently, there's now like over 100 different versions of SQL with different open source packages. And the end result was not a case of, hey, one database technology went to rule them all, as some people would have expected. It was a case of like, if you look today, every enterprises use an entire collection of several databases, all with their strengths and weaknesses, and applied them for different use cases. And that is going to happen with AI. We are already starting to see the early signs of that happening. Like, for example, AI models, even for the same architecture, right? We are starting to realize that, hey, image and video generations are prefer, let's say, the diffusion based architecture. And there's already a lot of open source image and video generation models. And likewise, text models may prefer a different set of architecture. And we start to realize these things, and as the cost to make these AI models go down, and they have been going down, we start to realize more and more players will create these open source models.
Right. Now, for the people who doesn't know, what you're doing is something that can simplify a lot of things for developers and people who want to build application over AI. Because what you do, you host one of the largest collections of AI models behind just one single API. So just instead of putting hundreds of API keys, so it just like one, and then you have access to all these models. Are you seeing any special patterns, like how developers and enterprise actually they are choosing models in production? And the reason I'm asking you this, Eugene, like even myself, I don't consider myself too much into the technical side, but these AI agents, like they let you scratch your head and say, "Hey, let me try this. Let me try this model." So, are you seeing any patterns on preferences, like what really developers and enterprises want, especially with the rise of agentic AI now?
Yeah. So it really changes depending on the stage of the company. I would say. So what we see very commonly is that when people first come to try open source models, um, probably because they are more familiar with the closed source models, they'll start with the biggest and the best. So we're talking about the latest generation of the Quen model, the Kimi model, or DeepSeek, like all these big names. And then subsequently, as they try and play around with these models, um, they they start to realize, hey, for certain specific use cases, I can use one of the open models that are specifically fine tuned for these tasks that are much more reliable for those specific tasks. And or the other path, respectively, could be, hey, my company has rather custom requirements, and I want to fine tune a model based on one of the open models to be able to more efficiently tackle this. So, for example, we have seen some financial institute where they specifically use some of the fine-tuned models to actually support coding and development work in their specific style of SQL and internal languages. Um, for example, also recently, Shopify, one of the major e-commerce player giants, they internally went to fine-tune a small 27B model specifically on Shopify's internal DSL programming language on how to customize the Shopify platform, which they are now exposing to all their customers through an AI agent, respectively. And they found that because they were able to tune it specifically to what they want, it was able to outperform even the best frontier model today in terms of the ability to modify the Shopify platform at a fraction of the cost. And so more and more companies are starting to realize as they scale up AI solutions, uh, that they can start to optimize this thing, customize these things, and to make things more tailored made to their platform at a much more efficient level. Um, it is still not something that is instantly done on day one, because as with any AI startup, I even advise your first step is to build the prototype and to get users to use it. Then your second step is to optimize it. If you're fine tuning your model at the very start, you might be fine tuning a model where there's only one customer, and that will not work.
Right. Now, back to what you mentioned before about this large language model and the bottlenecks. Do you think that the architecture of these transformer models itself becomes unsustainable at scale because of all the constraints we talked about? Like, and if yeah, what would be the alternative? And I know, like, you've helped developing and sorry if I'm not pronouncing the right name. I'm gonna say the abbreviations, the RWKV, which or some people call it the RKV, right? Um, so how this is the whole thing is also shaping the way we architect the model itself, Eugene.
Yeah. So one of the things that I find um, weird in current AI architecture is that its memory consumption, back to the HBM, scales quadratically with context length. So context length is the amount of tokens you put in. So the more as you chat longer and longer with ChatGPT, unless tricks were being done to compress it, the amount of memory it requires scales quadratically. This is unnatural. If I, as a human, for every second I'm alive, my brain needs to expand quadratically, By the time I'm 10, my brain will have exploded. It's an unnatural property of the AI model and architecture that we have developed in a way that works with the GPU. And and that is part of our scaling limitations. That being said, uh, there is research that we have done where the AI model is not just made of the attention layer, which scales quadratically, but also the MLP and MOE layer, which we have validated in some papers where it's able to hold a large percentage of the intelligence of the model. So this would also imply that there can be alternatives to attention. And that is part of our work where we experiment with more efficient attention alternatives that are scale linear in cost. And that's more like a human because for humans, we just burn the same amount of energy, give and take, for every second that we live. Our energy consumption don't increase quadratically. And part of the ongoing research is how do we apply these alternatives. The largest application of linear architecture would be currently the Quen line of models. And this is one of the strongest performing series of AI models that is on par with pretty much all the other open source models. But three-quarters of the AI architecture doesn't scale quadratically and scale
Mm-hmm.
linearly. What that translates to? Cheaper inference costs and less HBM demands. And this will be an essential part of making AI accessible. Because I talk about the like immediate practical sides of AI accessibility, like commercial side. Like more importantly, if we want AI to be the future driver of all the world economy, which a lot of people predict, we need to make it accessible to the majority of the world that doesn't speak English and and will need to be able to afford AI at a much lower cost.
Mm-hmm.
And if the minimum requirement for an AI model is $1 million server because of its high bandwidth memory requirements, we are missing out a large percentage of the population. How do we reduce that into the memory requirements that can run on a consumer grade GPU, for example? And that will make it accessible to anyone if, let's say, have a gaming laptop.
Very interesting points. I will try to make them in order, as a follow up to what you just mentioned. Let me start with this. So we know that because you talked about the GPUs, so we know like Nvidia and the others, mainly Nvidia, what we call it's their mode. It's not just the chips; it's the CUDA system. Like the ecosystem that they have created. They did fantastic in developer gravity. What I noticed recently, whenever they see something cool, they go and they implement it. For example, OpenClaw was one of the examples. So they adopted it somehow also as well. But realistically, what could weaken their dominance? And I know like once you weaken the dominance, so that means the pricing are going down. So what could be an event that can cause such a result?
So the fundamental shift will actually happen when users have a lot more choice that they can switch in between. And these and elements are slowly falling in place. In some cases, things even beyond like any major player's control. So take for example, um, today AI models are getting better and better at writing GPU code. And one of the things that I like to demystify about AI is that one thing that is nice about AI models from a coding perspective or even a math perspective is that if you try to re-implement the AI model code as a reference code from scratch, the average AI model is not even 1,000 lines of code. This is the case for when you typically implement it in PyTorch. It's really not that complicated. Once you know the fundamental theories, it's like, and we talk about AIs in layers. Each layer is exactly the same code in a for loop. Where it gets complicated is that simplified code is extremely inefficient to run. Uh,
Hmm.
it's good for as a mathematical reference, but it's inefficient, and you want it to run efficiently on GPU. So that's where each line of the code in that code base becomes another 1,000 line of code. and but AIs are actually getting better and better at writing that. So having the mathematical reference of the original. So this is whether it is to write it in CUDA, heap, heap being for AMD GPU, or even Metal for Apple's line of laptop or any other form of compute. So what as this increases, and it's already starting to happen, as people are trying to like optimize their AI models to run on their laptops or any mix of hardware, even or the CPU, the choices starts to open up. And that fundamental shift unlocks new hardwares and new possibilities. The other fundamental shift is the intelligence of AI is collapsing down towards smaller and smaller models, for example. One way I jokingly do this benchmark is take the highest end MacBook Pro for this year. I wouldn't call it cheap or consumer, but let's just use that as a reference. What's the level of intelligence of the best AI model you can run in that laptop? Yesterday or last year, it was ChatGPT 3. Now it's at Sonnet levels of performance. Like not the very best AI model, but one step down. Next year, potentially it will be the best AI model that you see today running on a laptop, a high-end laptop, even there. And and as that keeps happening, the best AI models you see today could be running on any hardware you can choose. That
Mm.
choice helps you drive the market changes respectively. The third category, which is the wildcard category, new hardware players are hungry to jump in. We know about Cerberus, we know about Drop, which got acquired by Nvidia. We know about a dozen of startups that are trying to enter the market with a new chip that is highly specialized for AI. That could change the market. I would say even Apple, which if I can put a mouth to their ear and be like, hey, you guys have one of the best AI chip in the market, but if you package it as a GPU, a PCIe card, and sell that, you will just ship volumes. But Apple won't do that because they're a consumer company. But
Right.
they can. So these things can fundamentally change the market as it provides users more options.
Just to give context for the audience, like I did a test and it was on an old laptop, but it had a GPU. I mean, it's not very old. It's like I think the M2 chip, the Apple Mac M2. It has a GPU built in, and yeah, I was able to run a one of the open source models. It's not like as fast as when you interact with maybe ChatGPT or any of the other tools, but I mean, still it worked because I proved the point. Yeah, like you can run it. Of course, like it was like kind of scrolling, like very slow, but it worked at the end. Like I even did something more crazy, and I found an even older machine that it happened to have I think one of the oldest GPUs, and still I managed to get it. Although like the CPU is like very old, it's a Celeron, believe it or not. But I yeah, but to your point, what I'm trying to emphasize on what you said, Eugene, is that like things are getting to the edge, as we call it, and I think this is something very interesting. Now, from your point of view, when because you are at intersection between hardware optimization and model research, so what kind of breakthroughs you think that they are currently underrated? Because we know the market, the VCs, everyone are looking, at the top guys, but maybe you are seeing few things that are really interesting, and you think like this will be major breakthroughs that are coming very soon, and we're gonna see something coming out of them.
So I have two versions of this. One is the pragmatic breakthrough, which is not really a breakthrough. It's just more of like as we understand the technology, and we improve on it. The bottleneck in AI application today is not the technology itself; it's AI reliability.
Mm-hmm.
And in my opinion, all the major labs are blindly chasing smarter and smarter models, which are not fixing reliability. We probably know a friend or two that is really intelligent, but is not able to consistently deliver their work on time. And that is essentially the problem with today's AI model. The best
Right.
AI model out of the box, unless they're specialized and fine tuned, is not able to do, let's say, a DoorDash order or Uber order with more than 80% reliability. And during that 20-30% failure rate, it may order 10 pizza instead of one. Will you
Right.
trust your credit card to someone who does that? And we're not, and these models, even the best one in open source, can do amazing feats like orbital physics calculation from Earth to Mars in seconds. I don't know how many of us can do that. So there is that disconnect. It can do this major feats of intelligence with, let's say, 10-20% chance of success, but it's able to do that, but it's unable to do simple tasks with consistency. And when you ask commercial companies, what do they want the AI model to do? Most of the time, they just want it to be consistent in a handful of tasks. And that is why more and more we see more and more companies customizing their AI models, fine-tuning, RLing the models. It, and this can be even small models like 27B models to achieve that 99% consistency, which is required to put things into production. And that has been one of the most silent pushes. Like like I mentioned, like we've seen Shopify, Cursor, and various major companies slowly do this behind the back. Another recent one is AT&T also fine-tune their own set of models for internal processes. And that is one major shift because it breaks free the dependency for extremely large models. The other one, which is from a more research side,
Mm-hmm.
is that I feel that we are fundamentally inefficient in the way we train models.
Mm.
And for good reason. You hear people talk about AI models being trained trillions of parameters to gain a certain level of intelligence. We have proof, very strong proof, that you do not need that level of tokens to train that level of intelligence. They are called human beings. We only give and take survive with, let's say, 100 years or 2 billion heartbeats. So if I say we for every second we live, is one token, that's 2 billion tokens. Some people say we have visual, audio, and all that. Fine. Let me be generous. 10 billion tokens. That is many orders of magnitude less tokens required to train an AI model. So, very fundamentally speaking, we are doing something inefficient in the AI architecture, which we are resolving via brute force. And to be fair, we really have brute force with the GPUs. So, as innovations into how we do the data efficiency improve, there is those fundamental drops in efficiencies to train the models at scale, whether be the amount of data required or even the size of the model. A good example that I point to that potentially highlights the inefficiency of text model. If you have seen image and video models, they are based on a different architecture line than the text model, and they're typically 10 to 20 billion parameters, and yet they can illustrate entire worlds. And yet at the same time, we sometimes struggle to get text models of the same size to be consistent in its text. It's fundamentally on how the architecture and how we train them differently. That is also part of our research to like how do we make AI models more efficient and
Mhm.
reliable at that scales.
Right. Eugene, there's one angle I think we didn't discuss. Now, we're talking about open source models, right? And we know they are improving. We discussed this, and you said like how they would be better by time. Now, similar to the era when the open source software appeared, and there was this debate, in the enterprise? Should we adopt, open source, or should we go like to a, traditional proprietary software to deploy the enterprise? Of course, the debate, one of them is that's out of the shelf. If something happens, we talk we talk to the developers or the company who developed that software. They have to solve it out. In case of open source, so either you have to have someone who's in your paying kind of support, quote unquote. Like I'm talking even about like people who might remember when we start to adopt in the enterprise, like things like Red Hat and Ubuntu and all these things. So yeah, we need support. The other way people looked at it, I can get people who understand, and because it's open source, I can modify it myself. So where do you see this debate, like or what you're noticing enterprises are doing when it comes to open source, how they think about it, like the trust, the the ability to, do they have to train also people internally so they can go and train these models or modify them?
So, for those who have done B2B deals at these enterprises, some of us may be familiar with the term the throat to choke.
Yeah.
Yeah, and that's essentially the role that we sometimes play for these companies. We will be there helping support them directly, helping them to ensure that the systems are all up and running for the open source model and meet their requirements, testing, etc. So that is something that Featherless play, as we do provide inference at scale, but it's something that pretty much any company that builds on top of open source model will play for the enterprises. So we see that happening, that's for sure. Because new technology, people are scared of the unknown. They want someone they can talk to. But what I find rather surprising as well is more and more companies as turning over for consistency and reliability. And I don't mean like the model, I mean consistency from their provider, um, from from the closed source models. And
Mm-hmm.
I say this mostly because, for example, from the existing closed source providers, the models are constantly being updated and deprecated on a monthly or even yearly basis. Uh, I have some enterprise customers who got very fed up that, hey, I just supported your model and you changed the model next month, and now I have to update my entire code base and platform and readjust it. And this happens monthly. And they'll be like, can we stop that cycle? Because if you are familiar with enterprises, some of them prefer yearly cycles or even 2 yearly cycles, with how they treat their software development. And the good thing about open models is if you do not want to upgrade and you just download and want to use that one set of weights, it's forever the same. And the other aspect is like we also seen enterprises now jumping on precisely because the current generation of open models have essentially caught up with Sonnet. OpenAI themselves, in one of their recent reports, admitted that 60% of their customers do not use the best model. That means
Mm-hmm.
for 60% of their customers, they can be fully replaced by the current generation of open models. And for all those who are very concerned about their code base, agentic code being used to train the next generation of open AI models uh, or etc., suddenly these open source models allow them to overcome their privacy fears because I can deploy this in their premise and they can air gap it if they want, and they never need to worry about their data being leaked or trained in future models.
Mm-hmm.
The third one is within the consumer space. Some is because the API keeps changing. We have seen incidents where some of the closed lab models, the latest models, degrade in intelligence when under heavy load, or because they didn't like a certain way you use the model, like in through OpenClaw and stuff like that. They specifically detect certain patterns and block your usage or bill you
Mm-hmm.
extra. And these things are frustrating to users because it's like, why are you dictating how we use the model at this level? I think the funniest one that was recently was because a certain line of agents was popular, the Hermes agent, that that users were finding themselves when it was detected there was a Hermes, they were being billed extra, and and it was detected by just the text Hermes.md, and a part of me was laughing because it was like, are you telling me potentially some developer in that Hermes bag company is suddenly being billed extra because someone decided that Hermes.md is not something they want to support? It's just that kind of eccentricity that's like, hey, we just wanting something that's more stable and controllable, that I actually get customers coming in when it happens. So yeah, I don't know why it happens. Version control is a soft thing. It's not an
Right.
AI problem. These $1 billion to $1 trillion companies should be able to do basic version control, yet they're not. That is issue on its own.
Yeah, two things I just want to quickly follow up. Agent Hermes is amazing, at least for me. I've been playing with it for now a couple of days. I liked it. It's a personal opinion. Liked it more than OpenClaw. And the main thing is the ability to the better memory there. The second thing, which you kept repeating, and actually, if people goes to the previous episode to this one, I had would be Helen Gu, and she talked a lot about that. Actually, she has a startup, and all what she does, with her team is about reliability of the AI. So I advise people to go and watch that. Um, Eugene, as we almost come to an end, final maybe words you want to share with the audience, and of course, where people can get in touch.
Yeah. Feel free to reach out to me, Eugene at Featherless.ai. Also, my socials are Pico Creator at Twitter. In other words, is open source models are pretty much here. Like, if you are dreaming of building any application, you can already start doing so and start iterating from it. Yeah. And that is the big shift for the year. Like, it shockingly surprised me that even, let's say, the 27B or 31B, those small models that can run on laptops like this, that
Yep.
has 128 gigs, can do entire applications just by prompting it. We're not even talking about the top of the line models like DeepSeek and etc. You can just build things. It's an exciting world. Like, you don't need to know how to code. You can just start building things. And I want to encourage people to explore that, because that is the exciting future that we are in.
Right. Quick question for you, Eugene. If I want to connect my Hermes agent with your API, will it choose the best one for me?
So yeah, we already have on our platform plans specifically for people who wants to run Hermes agents or OpenCloud. You can even host your Hermes agent on our platform. We provide one-click support for hosting these models. We also provide access to some of the latest models, be it DeepSeek, GIM, uh, Quen, that are does a really good job with these agentic tasks. And yeah, we encourage people to use it. It's
I
a
gonna
flat
try.
pricing. Yeah.
I gonna try it. And I encourage people to try. So for people who doesn't know what we're talking about, guys, if you it's not a hype. I'm telling you, like some people they say, yeah, this agentic thing is a hype. It's not a hype. I'm thinking to do a video just for this, and it's not like just to spread the knowledge, because the amount of you know time that I was able to save just in the past month between, of course, now I'm shifting from OpenClaw to Hermes. It's mind blowing, and I advise people to go. And of course, you would need something like Featherless, because probably you will not get the best speed if you run it locally, unless you can afford these these expensive GPUs. But yeah, like I advise everyone to do to give it a try. Eugene, thank you very much. Really, I like these discussions, and I like anything which is on the frontier of anything AI. And I think everyone should learn these things, because this is the future. And this is how I end my episodes. This is for the audience. First of all the links to Eugene's social and the website, of course, they will be in the show notes. If you're listening on your favorite podcasting app, if you're watching this on YouTube, they will be in the description. And if you just discovered us by luck, thank you for passing by. I hope you enjoyed. If you did so, give me a favor. Just share it with as many people as you can and subscribe. And if you are one of the people who keeps coming again and again, thank you very much for your support and thank you very much for what you're doing to the show. Despite like we changed some metadata in the show, still we managed to stay in the Apple Top 200 podcast chart across multiple countries, but now in the technologies section after we shifted from entrepreneurship. So thank you very much for the support. And as I say, always stay tuned for a new episode very soon. Thank you. Bye bye.